Hi students, in the previous section we have seen that the root of a quadratic equation a square plus bx plus c is x is equal to minus b plus or minus root of b square minus 4ac by 2a. X is equal to minus b plus or minus root of b square minus 4ac by 2a is the root of a quadratic equation a square plus bx plus c. In this section we have to study nature of roots. This is the last portion of the chapter, nature of roots. So we have the formula x is equal to minus b plus or minus root of b square minus 4ac by 2a. Here b square minus 4ac. This b square minus 4ac is called discriminant of the quadratic equation. B square minus 4ac is called the discriminant of the quadratic equation. Let us move on to the nature of the roots. There are three conditions. First condition is that if b square minus 4ac greater than 0, two distinct real roots. We have x is equal to minus b, x is equal to minus b plus or minus root of b square minus 4ac by 2a. This is the root of the quadratic equation a square plus bx plus c. Two roots are there, minus b plus or minus root of b square minus 4ac by 2a, which means x is equal to minus b plus root of b square minus 4ac by 2a, or x is equal to minus b minus root of plus or minus, which means minus b square minus 4ac by 2a. So if b square minus 4ac greater than 0, there are two roots, both roots are real. So x is equal to minus b plus root of b square minus 4ac by 2a, or x is equal to minus b minus root of b square minus 4ac by 2a. The second condition is that if b square minus 4ac is equal to 0, if b square minus 4ac is equal to 0, which means x is equal to minus b plus or minus root of if b square minus 4ac is equal to 0, that is minus b plus or minus, instead of b square minus 4ac, we are going to write 0 by 2a, which means x is equal to minus b plus root of 0 means 0, minus b plus 0 by 2a, or x is equal to minus b minus 0 by 2a. So we have two roots, x is equal to minus b plus 0 by 2a or minus b minus 0 by 2a, which means x is equal to minus b plus 0 minus b by 2a, or x is equal to minus b by 2a. So we have two values, x is equal to minus b by 2a or x is equal to minus b by 2a. So both roots are equal. So if b square minus 4ac is equal to 0, the two roots are equal, two equal real roots. Two roots are equal, both are real. The third condition is that if b square minus 4ac less than 0, b square minus 4ac less than 0, which means it is a negative number. B square minus 4ac less than 0 means it is a negative number. We didn't study root of a negative number, which is a complex number, which is not real. Therefore, if b square minus 4ac less than 0, no real roots. The roots are not real. So, these are the three conditions of the nature of the roots. First condition is if b square minus 4ac. B square minus 4ac means discriminant. If discriminant greater than 0, two distinct real roots. If discriminant is equal to 0, the two roots are equal. If the discriminant is less than 0, no real roots. Let us consider an example. Find the discriminant of the quadratic equation 2x square minus 4x plus 3 is equal to 0, and hence find the nature of its roots. First we have to find the discriminant of the quadratic equation 2x square minus 4x plus 3 is equal to 0. First I am going to write the quadratic equation 2x square minus 4x plus 3 is equal to 0. First we are going to find the discriminant of this equation. 2x square minus 4x plus 3 is equal to 0. Discriminant is equal to we studied discriminant is equal to b square minus 4ac. So b square minus 4ac. In this equation, 2x square minus 4x plus 3 is equal to 0. We have a is equal to 2x square, a is equal to 2, b is equal to minus 4 and c is equal to 3. So a is equal to 2, b is equal to minus 4 and c is equal to 3. We are going to find the discriminant of this equation. B square minus 4ac is the discriminant. Therefore, discriminant is equal to b square. Here b is minus 4. B square means minus 4 square. Minus 4 square minus 4ac. 4 into a is 2. 2 into c is 3. So, b square minus 4 whole square minus 4ac. 4 into a 2. 2 into c 3. It is equal to minus 4 square. Square of minus positive. 4 square means 16 minus 4 into 2 8. 8 into 3 24. So 16 minus 24. It is equal to 16 minus 24 is equal to minus 8. So we got the answer minus 8. So discriminant is equal to minus 8, which is less than 0. This is a negative number, so which is less than 0. So we got b square minus 4ac is equal to minus 8, which is less than 0. That is b square minus 4ac is less than 0. When b square minus 4ac less than 0, there are no real roots. So the discriminant of this equation is minus 8 and the nature of the root is there are no real roots. Let us consider another example. 3x square minus 4 root 3x plus 4 is equal to 0. We have to find the discriminant of this equation and hence find the nature of its root. So we have the equation 3x square minus 4 root 3x plus 4 is equal to 0. When we compare with the general form, a is equal to 3, b is equal to minus 4 root 3 and c is equal to 4. First we have to find the discriminant of the equation 3x square minus 4 root 3x plus 4 is equal to 0. So b square minus 4ac is the discriminant. So b square minus 4ac is equal to, here b is equal to minus 4 root 3. So b square means minus 4 root 3 square. That is minus 4 root 3 square. B square. B is minus 4 root 3. B square means minus 4 root 3 square minus 4 into AC. A is 3 and C is 4. So 4 into 3 into 4, which is equal to minus 4 root 3 square. Square of minus into minus plus square of 4 16 into root 3 square. Root 3 into root 3, which means root 3 into root 3 3 minus 4 into 3 12. 12 into 4 48. That is 16 into 3 minus 48, which is equal to 16 into 3, which is equal to 48 minus here 48. So we got 48 minus 48, which is equal to 0. So we got b square minus 4ac is equal to 0. So we got the discriminant b square minus 4ac, which is equal to 0. B square minus 4ac is equal to 0 means two roots are equal. Let us consider another question. Find the values of k for each of the following quadratic equations so that they have two equal roots. We have an equation 2x square plus kx plus 3 is equal to 0. We have to find the value of this k and we have condition they have two equal roots. So we are going to find the value of k. So we have the equation 2x square plus kx plus 3 is equal to 0. When we compare with general form, we will get a is equal to 2, b is equal to k, and c is equal to 3. When we compare the given equation with the general equation, we will get a is equal to 2, b is equal to k, and c is equal to 3. We have to find the value of k, and we have a condition that they have two equal roots. We studied that if the roots are equal, then the discriminant is equal to 0. If b square minus 4ac, that is the discriminant, if b square minus 4ac which is equal to 0, then the roots are equal. Here we have given that they have two equal roots, which means b square minus 4ac is equal to 0. So we can find the value of k. We have a is equal to 2, b is equal to k, and c is equal to 3. Since they have two equal roots, b square minus 4ac discriminant is equal to 0, b square minus 4ac is equal to 0. Let us substitute the values of a, b, and c. b square means k square minus 4ac. 4 into a is 2, c is 3, which is equal to 0. K square minus 4 into 2 into 3. 4 into 2, 8. 8 into 3, 24. K square minus 24 is equal to 0. K square minus 24 is equal to 0, which means K square is equal to, when minus 24 goes to RHS, it will become plus 24. K square is equal to plus 24. So taking square roots, k square is equal to 24, taking square roots, then k is equal to root of 24. Not only root of 24, plus or minus root 24. Therefore k is equal to plus or minus root 24. That is k is equal to plus or minus, we can take 4 outside. So when we take 4 outside, we will get 2, and inside the bracket 6. So k is equal to plus or minus 2 root 6. So b square minus 4 is equal to 0. Substitute the values of a, b, and c. We will get the value of k. K is equal to plus or minus 2 root 6. So we got the value of two values for k, plus 2 root 6 and minus 2 root 6. Let us consider another example. We have to find the value of k. We have two equal roots for this equation. So first we are going to expand this equation. Kx into x, which means kx into x, kx square, minus kx into 2, which means 2kx, plus 6, which is equal to 0. We expanded this equation. We got kx square minus 2kx plus 6, which is equal to 0. This is a quadratic equation. So we are going to find the value of k. We have the condition that two equal roots are there. So when we compare this equation with general equation, we will get a is equal to k, b is equal to minus 2k, and c is equal to 6. When we compare this equation with the general equation, we will get a is equal to k, b is equal to minus 2k, and c is equal to 6. We have two equal roots, therefore b square minus 4ac, which is equal to 0. b square minus 4ac is equal to 0. Substituting the values of a, b, and c, then we will get b square means minus 2k square. b square means minus 2k square, minus 4 into a is k, 4k into c 6, which is equal to 0. So we got minus 2k square minus 4 into k into 6, which is equal to 0. Minus 2k square means square of minus positive, 2 square 4 k square minus 4 into k into 6, that is 24k, which is equal to 0. So we got 4k square minus 24k, which is equal to 0. Let us take 4k outside. When we take 4k outside, we will get 4k outside. When we take 4k outside, we will get remaining k minus. When we take 4k outside from 24k, we will get 6, which is equal to 0. So we got 4k into k minus 6 is equal to 0. 4k into k minus 6 is equal to 0, which means either 4k is equal to 0 or k minus 6 is equal to 0. 4k into k minus 6 is equal to 0, which means 4k is equal to 0 or k minus 6 is equal to 0. 4k is equal to 0 implies k is equal to 0 or k minus 6 is equal to 0, which means k is equal to positive 6. So we got two values for k, 0 and 6. So the value of k be either 6 or 0. So we got the two values for k, 0 and 6. So we have studied how to find the nature of the roots of the equation, as well as if the roots are equal, we can find the values of k. So in this chapter, we studied the roots of a quadratic equation by the method of factorization, by the method of completing the square, and by quadratic formula. And also we studied the nature of the roots of the quadratic equation. So there are so many problems we have to discuss. When the regular class is open, we can continue with the problems. Okay, thank you.